Graph theory is the study of graphs, the relationships between edges and vertices. It falls under a branch of math known as discrete mathematics. Discrete math focuses on structures that are discrete, such as logic or combinatorics, rather than continuous, such as calculus. So where did graph theory begin? Here's a quick history lesson. In 1736, mathematician Leonhard Euler traveled to Königsberg, Prussia. Königsberg was notable for its 7 bridges. It was heavily debated if there was a way to tour the whole city while crossing each bridge once and only once. Euler thought of an interesting approach to this problem. He symbolized each portion of land as a vertex and each bridge as a line, or edge. This modeling allowed Euler to discover that a path in which each bridge was traversed once and only once was not possible. A path such as this became known as an Euler path. It can only exist if the graph is connected with 2 or less vertices of odd degree. The path can be accomplished by starting at one vertex of odd degree and ending at the other. Euler's work in 1736 is widely considered to be the birth of graph theory. An interesting application of graph theory is vertex coloring, coloring a graph in such a way that no 2 vertices of the same color are adjacent or connected to one another. We want to color efficiently so that the chromatic number or minimal proper vertex coloring is achieved. The example coloring from earlier was done correctly, but we want to find the chromatic number. If we redraw the graph from earlier, we can color the first vertex color C1. The next vertex can't be colored C1 because it's adjacent, so we'll color it C2. Similarly, the next vertex will need to be colored C3, since it's adjacent to color C1 and C2. We will continue doing this until the graph is completely colored. We find that the chromatic number is 3.
Alright, so here's an application. Say you're planning a party at the Krusty Krab. You want to seat people in such a way that no 2 people who don't like each other are seated next to each other. How might you do this? Well, you're given a list of people's least preferable table mates. Let's construct a graph.
Here's that list of preferences. We can label each guest as a vertex and draw an edge between the guests and their least preferable table mates. From this we can color. We find that the chromatic number is 3, so we can set up 3 different tables where there will be no guests sitting next to their least preferable table mates.
While the Krusty Krab example may not be the most practical use of vertex coloring, some of the real-world applications of vertex coloring are. They can be included in job scheduling, aircraft scheduling, and even GSM phone networking. But beyond this, graph theory can do so much more. Graph theory is currently being used in developing digital networks, modeling the brain, and even understanding galaxy distributions. Since its origins in Königsberg, graph theory has become a way to creatively problem solve and reduce complexity. Its applications are nearly limitless, making it able to serve us better in research for STEM and advancing us towards the future.
If you are interested in learning more, here are some sources. Thanks for watching.